Hi everyone, so this is tutorial sheet 3, question 11 on complex numbers. So I'm going to start with this first question here. I'm going to solve it. And I'll also solve question 2 and probably even question 3. And I'll show you how to solve question 4 and 5. I don't want to be making the videos long, but I'll show you how to solve them. That's the reason why I only solve part of each and every question and leave some questions out. So we start. So this is the question, and then so the first thing that we're going to have here, or that we're going to do here, is to take this this negative I, that side, on the other side of the equal sign. So we're going to have something like this is equal to positive I. Now, since the question is telling us to solve the equations and showing the solutions on the Argand diagram, so I'll start first by solving the equation. So by solving the equation, they are simply asking me to make z, or to leave z alone. Z should not have any power. So I'm going to find so I'm going to find the fourth root of z this side, and I'm also going to find the fourth root of this. So we're going to have z is equal to, let me use this kind of z so that at least there's supposed to be a difference between this z and the two that I'm going to be writing. And then, so the fourth root of this can also be written as the fourth root of 0 plus I, like that. The fourth root of 0 plus I. So this is just the same as that. So our z can also be written as, you open the brackets, 0, then plus I. Then this fourth root can also just be written as, it's just the same as 1 over 4 to the power 1 over 4. So at least now, from this point, most of us can take it up. But I'll go further and I'll finish it up. I'll solve everything. So after finding this, remember what you said. You first identify which one is your n. So my n here is equal to 4. And then the values of k, remember what you said. The values of k are just numbers from 0 up to n minus 1. So from 0 up to 4 minus 1, I'm going to have 3. So meaning I'm going to have my k numbers from 0 up to 3. So these are the values of k. Then apart from this, we can now find the argument and the magnitude of this complex number. So the reason why I'm finding the argument and the magnitude of the complex number is because I cannot find the roots of a complex number without changing it into polar form. I first have to convert it into polar form, and when converting it, I always have to find the argument and the magnitude. So the argument of this complex number, or let me start with the magnitude first. The magnitude r of the complex number is nothing but the square root of 0 squared. So 0 squared plus 1 squared. Remember, it's x squared plus y squared. So this one will give us something like this. 0 plus 1 is 1. So the square root of 1, you get your answer to be 1. So from there we find the argument now. So the argument, which is abbreviated as ARG, the argument of z, so the argument of z the argument of z is equal to so the argument of z is equal to y over x. So y over x is just nothing but I mean tan inverse of y over x, tan inverse of y over x. So my y here is just the coefficient of I, and then my x is 0. So my y is 1, the coefficient of I there is 1, then divide by 0. But remember, any number divided by 0 gives what? Infinity. So tan inverse of infinity, let me just do this. So 1 over 0 is just the same as tan inverse of infinity. So the tan inverse of infinity is the one, so tan inverse of infinity is equal to 90. So 90 degrees is going to be our argument. So if you want, you can convert it into radians or just use it like this, the way it is. So now we can write our complex number in polar form. Our complex number z in polar form is going to be, I'll open these brackets, the square brackets, and then inside there I'll write my magnitude. The magnitude of z is equal to 1. So I'll write my 1 there, and then open brackets. Then the complex number z in polar form will be cos, before we write the complex number in polar form, we first have to check where this complex number lies. So the complex number is 0, and then comma in the real axis we are moving 0 units, meaning we are just still on this origin, and then in the imaginary axis we are moving I units. So our complex number is going to be, it's going to move in this direction. So this is how our complex number is going to be. So this is our complex number z. So meaning it's at 90 degrees exactly. So what we're going to do is we're going to write the same 90 since it's still in the first quadrant, which is all positive, meaning we just write the same 90 degrees. So to be cos 90 and then plus I sin 90, I sin 90. Okay, so it's going to be I sin 90 degrees, and then apart from that we don't have to forget to put the power 1 over 4. Alright, so now since we have this, we can now start using our k values to find our complex numbers. So first find z1. So z1 is equal to this 1 times everything there, you still get 1. So in short, I'm going to 1 to the power 1 over 4, I'll still get 1. Alright, let me just write it for the sake of you knowing what is happening. 1 to the power 1 over 4. Then this complex number also raised to the power 1 over 4. So cos 90 plus I sin 90 to the power 1 over 4. So this 1 to the power 1 over 4, you still get 1. 1 times everything there, you get the same things again. But remember, when you do this, you have to add this angle plus 360. Let me just say plus 360k over n, 360k over n. So you add all this and then divide by n. My n is equal to 4. So my k there, for k, oh sorry, I'm finding k0 not k1. So my first k there is 0. So to be k0 is equal to that. So where there is k here, I'm going to put 0. 0 times everything there to give me 0. And then 0 plus 90, I'll get 90. So 90 divided by 4. Let me write my z0 here. Hope you know what I'm doing. So 1 to the power 1 over 4, I'll still get 1. 1 times everything there to still give me those same things. Then 90 plus 360 times 0, I'll get the same 90. Divide by 4, my answer will be 22.5. So I'm going to have cos 22.5 plus I. So this same angle that you have here is the same angle that you put there. So to be I sine 22.5. I sine 22.5. So this is going to be your z0. So if you want, you can take it in the form x comma y, back to this same form here. And if you want, you can leave it like that. But for me, since I'm drawing the Argand diagram, I prefer leaving it like this. So this is my z0. So move on to z1. So z1, what will change in this one is just the angle, since we know that the magnitude there will still be the same. So my z1 is equal to cos, of course my magnitude is equal to 1, which is outside there, is 1, and then 1 times everything will still give me the same thing. So I'm omitting it here. 1 times what I'm going to write will still give me the same things that I'm going to write. So let me just omit it. So cos, this is going to be 90 plus 360. My k now is equal to 1. Then everything over 4. Plus I sine sine 90 over 90 plus 360 times 1, then everything over 4. So now z1 will now be equal to, we just work out the solution here, 360 plus 90. So you get cos 360 plus 90 over 4, you get something like 112.5, then plus I sine the same angle, 112.5, sine 112.5. So this is my z1. Let me find z2 also. So for z2, if I want, I can first start by finding the angles. So z2, it will be 90. My angle is going to be 90 plus 360, where there is k, I'll put 2 over 4. So my angle is going to be this, which will give me 202.5. 202.5. So my Z2 is going to be, so the argument of Z2 here, I'll just put ARG of Z2. Then so my Z2 now will be equal to cos 202.5, then plus I sine 202.5. So this is going to be my Z2. Let me now find the last one, which is Z3. So my Z3 is going to be, so let me first find the argument for Z3. So the argument for Z3 is going to be 90 plus 360. So 360, my Z is going to be 3, then everything being equal to 4, which gives me the answer to be 292.5. So 292.5 will be my Z, my argument for Z3. So Z3, I can now write it as Z3 is going to be cos 292.5, then plus I sine 292.5. 292.5. So this is going to be my Z3. So now we move on to drawing the Argand diagram, since we have found the solutions for our complex number Z. So let us now draw our Argand diagram. I just draw a small one here. Of course it has to be labeled. So this is my imaginary axis Y, then this is my real axis X. And then, so what we do here is it's going to be like this: 0, this is the origin, and of course this side is still going, this side is also still going. So now let us start drawing our complex numbers. Yeah, so you just check your arguments that you have been given, and the simplest way is this: if you have a protractor which can measure angles, it's even better. But if you don't have a protractor, you convert these complex numbers into rectangular form. You convert them into the form x plus I, x plus iy. sorry. So you convert them into this form if you want to just plot them. Let's say, for instance, if you convert this, if it gives you something like maybe root 2 here and then comma 1, you can plot it to be like that with a magnitude of 1. You see? But if you don't have a protractor and a ruler, you can just approximate, and it's easier that way when you use angles, where you say, okay, this is going to be my 1. So I'm going to draw a circle of magnitude 1, of radius 1, sorry. I'm going to draw a circle of radius 1. Let me just change the color. I'm going to draw the circle of magnitude 1. So, sorry, I'm going to draw a circle of radius 1. So this is going to be 1. This will also be 1. Why am I drawing a circle with radius 1? Somebody might ask, where has he gotten this 1? So my 1 is just the magnitude. The magnitude that I had. Let me just show you. So this was my magnitude, which is 1, of the complex number. So I'm drawing a circle of radius 1. So this is how it's going to be. So this will be my negative 1 this side. So this is a circle. So the way I'm going to draw this is like this. I'll first go on Z0. What is the argument for Z0? So the argument for Z0 is where is Z0? Oh yeah, is 22.5. So 22.5 is the argument for Z0. So these angles are measured starting from the positive x-axis. So the argument for Z0 is going to be 22. Where is it? Argument for Z0, we said 22.5, yeah. So it's going to be here. So if you have a protractor, you measure the angle 22.5 there. Make sure that it doesn't exceed the circle, because it's showing that your magnitude of that is 1, and then the argument is 22.5. That is going to be your argument like that. And then from there, you are going to measure 112.5. Okay, so let's draw another one. Here it's going to be, we draw again. I'm just approximating the angles. So we are going to draw the next one, which is 112. But 112 cannot be like this. 112 somewhere there. I'm just approximating with a magnitude 1. So it's going to be like that. This is 112 degrees, 0.5 degrees. So if you have a protractor, you are supposed to be accurate on this one. Then you move on to Z. So this was my Z0. You have to name them. So when is your Z1? Move on to Z3 or Z2. So Z2 the angle was. So for Z2 the angle was 202.5. So 202.5, I'll approximate it to be like somewhere there. So 202.5 to be somewhere like that. So if I don't want to write the whole angle here, 202, since it wouldn't look neat, so I'm just going to subtract I'm going to subtract 202.5 minus 112.5, which gives you 90. So I'm just going to draw a 90 degrees angle here. After that, I move on to the last angle now, which is 292.5. So 292.5 is going to be somewhere there. Same applies here. If I want to show this neatly, I will not write a line that is going to start from this side up to that. No, I'm just going to measure this angle. And how do I measure this angle? It's by subtracting. This is Z. This is Z2. Let me now put this is Z3. So I'm going to subtract this 202.5 from 292. Which also gives you 90. This is awesome. Also gives you 90. So this one is also 90. Yeah. So this one is also 90 degrees. So this is how your Argand diagram is going to look. This is what it's going to look like. So let's move on to the next question. On this one I'll be a little bit fast. This is Z to the power 3 is equal to negative root 3 minus I. So the next question is saying, let me just change the color. Z to the power 3, this is question 2. Okay, Z to the power 3 is equal to negative root 3 minus I. Then, so after that, this can also be written as Z is equal to, so the cube root of negative root 3 minus I, which is just the same as open brackets negative root 3 minus I, then to the power 1 over 3. Okay, so this is how you can write it. Then we move on. First thing we identify which one is our n. So our n is going to be this number here, which is 3, or this one, or that one. That is our n. So our n is going to be 3. Then our values of k will be from 0 to n minus 1. So 3 minus 1 you get 2. So the value of k is going to be 0, 1, and 2. So these are the values of n that we're going to have. Then from there we find the magnitude. So the magnitude is going to be, so our r, the value of r is going to be the square root of negative root 3. So the square root of negative root 3 squared, then plus the square root of negative 1, oh sorry, not square root, so plus 1 squared. This is negative 1 squared. So when you find here, when you calculate this, you're going to find the square root of 4, which is just the same as 2. So after finding these two, you quickly move on to finding the argument. So the argument, of z, so the argument of z is going to be tan inverse. So tan inverse of y over x. So our y is -1 and then our x is -√3. So it's going to be -1 over -√3. When you look at this is a special angle that we're going to get out of that. So when you find tan inverse of 1 over -√3, your answer will give you 30. So 30 is going to be your answer. So after finding the argument there, you now check in which quadrant is there. Is the complex number. The quadrant is going to be, so when you approximate, this is -√3 there in the real axis, and then in the imaginary axis -√3. So meaning our complex number is somewhere there. So this simply means that we're going to move like this. So the theta that we found is this one here, which is 30. So our theta that we found there, our z, the argument of z is this one here, which is 30. So if you want to find the whole angle, this one, you have to add it with this 180. So 180 plus 30, you get your argument. So the argument of z, is not necessarily 30, but it's going to be 180 plus 30, which gives you 210. So this is the argument of z. Yeah, so now from here we can now find the arguments when k is equal to 0, the argument when k is equal to 1, the argument when k is equal to 2. So when k is equal to 0, the argument is going to be 210. It's going to be 210 plus 360. Where there is k, we put 0. Then everything divided by the value of n, which is 3. So my argument there, I'm going to get 210 divided by 3, which gives me 70. So the argument that I'm going to get there will be 70 degrees. Move on to the next one here. So when k is equal to 1, we're going to have 210 plus 360. Where there is k, we put 360 times 1, and then everything divided by 3, which gives you 190 degrees. So 190 degrees is going to be your argument when k is equal to 1. So when k is equal to 2, where there is k, you just replace with 360, or where there is k, you replace with 2. You put 2 there. Alright, and then you divide everything by 3. So you get your answer to be 310. So these are going to be your arguments. So after finding the arguments, you now write your solutions. Since the question is saying find the solutions, if the question was not asking us to find the solutions, we would have drawn the Argand diagram just from here. Now the question is saying we should also find the solutions. So what we do is you write, so when k is equal to 0, you're going to have your z to be equal to your magnitude, the magnitude we found 2. So you raise 2 to the power, let me just scroll it up, to the power 1 over 3. So 2 to the power 1 over 3, and then open brackets, we say cos. So this is going to be give you cos. So this is going to be cos what? Cos 70 when k is equal to 0. So this is our z0, cos 70 plus I sine 70. In other words, this is the simplest way you can master all the processes of doing this. Okay. Then when k is equal to 1, you find your z1. So your z1 there will be, the magnitude will still be the same, 2 to the power 1 over 3. So 2 to the power 1 over 3, and then multiply everything by cos the angle, which is 190, cos 190 plus I sine 190. Alright, so from there again you take your k. When k is equal to 2, you find your z2 there. So your z2 is going to be, the magnitude will still be the same, 2 over 3, and then this is going to be cos 310 plus I sine 310. Then you put them in brackets like that. So this is how you find the solution. So these are the solutions for the question. Now we move on to drawing the Argand diagram. We put them on the Argand diagram. So as I earlier on said, it's better to use angles than to start measuring using the ruler. So when you have a protractor, these things are straightforward. So first thing, you plot your 70 degrees with the magnitude of that. So you draw a circle of radius, the magnitude of the thing. So the magnitude, this 2 to the power 1 over 3 is just the same as the root of anyway, let me just write it like that, but it's just the same as the cube root of 2. So I'll do this. I'll draw a circle first. Sorry. So this circle is going to be like this. So the magnitude of this circle, the radius of this circle, is 2 to the power 1 over 3. Even here I have 2 to the power 1 over 3. I move on here, I have negative 2 to the power 1 over 3, like that. Even this side, negative 2 to the power 1 over 3, like that. So after writing that, we can now start drawing our complex numbers. So our complex number, the first complex number that we have here has the argument 70. So I'm going to approximate my 70 here. But for you guys, I emphasize, use a protractor. I'm doing this because I don't have a protractor right now. So I'll approximate my 70 to be there. So this is my 70 degrees. So this is going to be my Z1. Then when you subtract there, 190 minus 70, 190 minus 70, you get your answer to be 120. So you draw 120 from there, or if you want you can just draw 190 from this angle, like that. Then you go, so 190 is going to be somewhere there, and then it's going to be like this. So this is going to be my 120. 120, when you subtract, so this is your Z2. and then your 310 is going to be somewhere there. Of course, the difference between 190 and 310 is still getting 120, like that. So use a protractor to measure these angles. When you measure this angle between 70 and this angle here, 310, you discover that it will also give you, I think, 180, because from 310 to 360 there is 40, is it? Or there is 50. Then 50 plus 70 you discover that this is also 120. And then this is your Z3. So this is how you draw the Argand diagrams. Very simple. Hope you have understood. Let's move on to the next. So let me do question 5. Question 5 is Z is equal to I plus 1 plus I, and then root 3 plus I. 1 plus I, root 3 plus I. 1 plus I. Then we have root of 3. The root of 3 plus I. When you do question 5, you first simplify it. You simplify it. You first find the conjugate of that to simplify. Or if you don't want, you can first convert the top part here into a complex. Now, let me check first. Right? Let me see how it is. To the power 1 over 6. Alright, to the power 1 over 6. Sorry, is to the power 1 over 6. So this one can also be written as Z to the power 6. So you do this, you raise this to the power 6. So this is going to be Z to the power 6 is going to be equal to, and then this 6 times 1 over 6, you get 1. So you're going to have something like this: 1 plus I, and then everything over the root of 3 plus I. So now, after doing this, you can now first convert the top part into polar form and the down part into polar form, and then divide them the way we're dividing complex numbers. So when you convert the top part, or by converting the top part, we're going to first have the magnitude of the top part is going to be 1 squared. So it's going to be 1 squared plus 1 squared. It's going to be root 2, like that. Root 2. You can solve it on a separate paper, root 2, and then open brackets. And then when you find now the argument of this is just going to be 1 over 1, and then tan inverse of 1, we all know that is 45. So it's 45. So we're going to have cos. We're going to have cos 45 here, minus, oh sorry, not minus, plus I sine 45. So this is how it's going to be. Then everything over this one, you convert this one as well. So when you convert this one, you find the magnitude of this the magnitude is going to be 2. And then when the magnitude is 2, you open the brackets like that. They are going to have cos. The argument of course is going to be 30. Why 30? Because it's going to be tan inverse of 1 over root 3. So tan inverse of 1 over root 3, you get your answer to be 30. So it's going to be cos 30, and then plus here I sine 30. The reason why I'm doing it very quick like this, I don't want to spend a lot of minutes in this video. Yeah. So now we can now start dividing the complex number, the usual way we do it. So how do we divide the complex numbers? You divide first the magnitude. So when you divide root 2 over 2, you still have your answer to be root 2 over 2. This is an irrational number. So you leave it how it is like that. And then from there, so when you're dividing complex numbers, you simply subtract the angles. So you simply subtract the angles. So you're going to have open brackets, and then this is going to be cos 45 minus 30, you get 15, and then plus, so this is going to be 15 degrees, then plus I sine, again you write the same 15 because you're subtracting 45 minus 30. -15 like that. So this is how you divide, and then I forgot to write 60. So this is now the one that you find the cube root and everything. So how do you do it? You say Z will now be equal to, you open these curly brackets, then root 2 over 2, and then open these brackets, cos 15 degrees plus I sine 15 degrees, close brackets, and then everything to the power 1 over 6. So from there we only to say everything there to the power 1 over 6. So our magnitude, yeah, so since before we find the magnitude there, this one can also be written as what? The root of 2 over 2, then to the power 1 over 6, yeah, and then you open brackets, cos 15 degrees plus I sine 15. Let me just move it a bit this side. Okay, sine 15 degrees, then everything to the power 1 over 6. So now I think from here we can even start doing what? We can even start finding the roots. So before we start finding the roots, we can first find the values of k. So the values of k, when we're going to have first, the value of n is equal to 6, of course, this 6. So the value of n is 6. Then the values of k will be equal to, the first value of k there is going to be 0. Then we're going to end at the number which is n minus 1, which is 6 minus 1, which gives us 5. So 0, 1, 2, 3, 4, and 5. So these are going to be the values of k. So when we have our k to be, so when k is equal to 0, our argument, when k is equal to 0, let me just say k is 0 is equal to, let's find the argument when k is equal to 0. Before you start finding the argument, first I would advise you guys to check the angle and to check the quadrant where this complex number lies. So when you find cos 15 using compound angles, so cos 15 is nothing but just subtracting 45 minus 30. So you can use 45 and 30 as your special angles to find the value of cos 15, where you just subtract 14 minus b there, which is 30, and then you replace them this side and then find the answer. So cos 15, when you use that, you get a positive number, and then sin 15, when you calculate, you also get a positive number. Alright, I was just testing. So meaning if they are all giving you positive numbers, it simply means this complex number lies in the first quadrant, like that. So meaning the angle that we're going to use is the same 15, to not change. So k0 is going to be 15. When k is equal to 0, the argument is going to be 15 plus 360 times 0, 360 times 0, and then everything over the value of n, which is 6. So 15 divided by 6, 15 divided by 6, you get something like, so 15 divided by 6, you get something like 5 over 2. This 5 over 2 is not in radians, it's just in degrees, so you just write 5 over 2 like that, 5 over 2 degrees. Or if you don't want 5 over 2, you can write 2.5, which is even better. Let me just write 2.5. So you're going to write 2.5 degrees. So this is going to be your k0. Then you move on to finding the angle when k is equal to 1. So when k is equal to 1, your argument is going to be 15 plus 360 times 1. So 360 times 1, you simply get the same 360, then everything divided by 6. So 360 plus 15, 360 plus 15, you get 375, and then when you divide 375 by 6, you get 62.5. So your next argument here is going to be 62.5. 62.5. Then when your k is equal to, 2, the argument that you are going to have is 15 plus 360 times 2. So 360 times 2, you get 720, and then 720 plus 15, you get 735. Then everything divided by 6, you get 122.5. So from there, you move on. When your k is equal to 3, you're going to have 15 plus 360 times 3, then everything divided by 6. So 360 times 3, you get 1080, and then you add it with 15 there, you get 1095. Divide by 6, you get 182.5. 182.5, that's going to be your answer. Then you find your K4. So your K4 is going to be 15 plus 360 times 4, everything divided by 6. So 15 plus 360 times 4. So 360 times 4, 360 times 4, you get 1440, and then you add it to 15, you get 1455. Divide by 6, you get 242.5. So it is 242.5. So 242.5 degrees. All these are in degrees. 1, 2, 3, 4, 5, and then we find our last K, which is the K5. So when K is equal to 5, our value of so when K is equal to 5, our value of the argument is going to be 15 plus 360 times 5. So 360 times 5, then everything divided by 6. When you calculate that, you get 302.5. So 302.5 degrees. So now, having found the arguments, we can now proceed to find the solution. So when K is equal to 0, so when K is equal to 0, where is my K is equal to 0? Yeah, when K is equal to 0, my Z0 is going to be like this. So my Z0 is going to be, what is my magnitude? Let me check the magnitude. The magnitude is the root of 2 over 2 to the power 1 over 6. So the magnitude is the root of 2 over 2, then everything to the power 1 over 6. Everything to the power 1 over 6. And then the complex number in polar form is going to be cos 2.5. You get this argument when theta is equal to 2.5, the argument which is 2.5. So it's going to be 2.5 degrees, then plus I sine 2.5 degrees. So when Z is equal to 1, Z1 is equal to, you repeat the complex, you repeat this part here, which is the root of 2 over 2, and the magnitude is just the same, with 6. So 1 over 6, and then you open, another bracket here, say cos 62.5, 62.5 or 62, so 62.5, then plus I sine 62.5. You move on to Z2. The solution for Z2 will be the root of 2 over 2, then everything to the power 1 over 6. then open bracket, then cos 122.5 plus I sine 122.5. Move on to Z3. So Z3 is equal to, so you repeat the argument there, root 2 over 2, then everything to the power 1 over 6, then cos 182.5 plus I sine 182.5. Z4, so Z4 is going to be, so you can write it the way it is and just be changing the arguments there, which is so it's going to be root 2 over 2 to the power 1 over 6. Then my argument is going to be 242.5 degrees. It's just another way of writing polar forms. So my Z5 will still be the same. Which is going to be the root of 2 over 2, open and close brackets. So this is going to be 1 over, oh sorry, this is not supposed to be 1 over 6 or 1 over 2, but 1 over 6. 1 over 6, and then the argument is 302.5. 302.5 degrees. So now, having found this, we can now start drawing the Argand diagram. So the Argand diagram is going to be this one. So alright, this is my real part. This is my real part X. And then this is the imaginary part, 1. Okay, so it keeps on going this way and that way. Then this is 0. Then I'll write the circle like that. Me personally, I advise people to use when drawing the Argand diagram to use it in polar form, not in rectangular. But even in rectangular, it's straightforward. But polar form at least is easier when you even have the protractor. So we start first with the first argument there. The first argument was 2.5 degrees. So I'll measure my 2.5 approximately. Let me just change the color. Okay, so first of all, I put so this circle, the radius of this circle is supposed to be equal to the magnitude of the complex number, which is the root of 2 over 2, then everything to the power 1 over 6. Even here, the root of 2 over 2, and then everything to the power 1 over 6. no, yeah, even here this side it will be negative the root of 2 over 2 everything to the power 1 over 6, even there to be negative the root of 2 over 2, and then everything to the power 1 over 6. So now, having done this, we can now start drawing the complex numbers. So the first argument we had was let me just use blue. So the first argument that we had was 2.5. So I'll write my 2.5. So this is going to be my Z1, and then I'll denote this one as 2.5 degrees. Then I'll measure another angle now, which is 60. Was it 62.5? Yeah, 62.5. So 62.5. 62.5, when I subtract it from 2.5, meaning I'm going to measure a 60 degrees angle from this line to that. So 60 is going to be somewhere there. So this is going to be my Z2. So I'll put 60 there. 60 degrees. Then I'm going to measure my Z3 with the magnitude of the angle to be 122.5. So 122.5, I'll measure another. So 122.5 minus 60, 122. So 122.5 minus 60. You get 62.5. So it's just the same as drawing another 60 degrees here. Sorry, this is going to be a Z3. So this is 60 and then another 60 there. Then from Z3 you move to the next one, which is Z4. Sorry, this one was Z0, this one Z1, not Z2, and then this one will be Z2. Yeah, so now we'll move on to Z3. So Z3 is 182.5. 182.5, which is somewhere there. So this is going to be a Z3. So Z3 is going to be like this, 182.5, which is just the same as just putting another 60 there. So take note of these angles. So if the difference between the angles are not the same, not to say your answer somewhere you went wrong, your answer is not correct. So if the angles in between are consistent, just know that you've gotten it right. So we move on to 242.5. So 242.5 will be somewhere there. So this is my Z4. I'll measure my 60 again there. So this will be 60. Why am I measuring 60? Try to subtract 242.5 minus 182.5. You get your answer to be 60. So if the angle between the complex numbers and is not consistent or not consistent, just know that somewhere you went wrong. Then you move on to Z5, the last one, which is 302.5. So 302.5 can be somewhere there, approximately somewhere there. So this is my Z5. and then this is going to be another 60. Sorry, it's going to be another 60, and then this one also will be 60 degrees. So this is how you draw the complex numbers. So I've done question 1, I've done question 2, and I've done question 3. Oh sorry, I didn't do question 3, but I did question 5, the last one. I did it because it looked more complicated than the others, and hence I picked it. So the way I've done question 5, that's the way you do question 4 as well. The way I did question 1 and 2, that's the way you do question 3. So thank you very much for watching these videos. Make sure that you subscribe to the channel. Don't forget to subscribe. And when you have any questions, any contributions, and any corrections, you simply send them to this line here. And if you would like our channel to be improved in a certain way, you should also send your request to this line on WhatsApp. Yeah, thank you very much. Stay tuned to the channel. Don't be missing the videos that we're going to be posting on this channel. For more information, you should send your text to this channel. See you next time in the next tutorial video.